So I'll pass it over to Glenn Westendorp from the town of Comox. Walk through a case study.
Chris? Just want you to know that I plagiarized this saying before Nancy did. Slow it, sink it, spread it. A simple saying that I believe summarizes the means by which we can manage rainwater to alleviate both drought and flooding. This saying also summarizes the purpose behind the Water Balance Model Express. Why are we here today? Faced with the ever-increasing extremes in our weather and limited resources to address these extremes, we need to initiate a change in our land use. The WaterWise Guide and the Water Balance Model Express provide us a means to engage and educate homeowners and the development community on what is possible. Water Balance Model versus Water Balance Model Express. The chief difference between these two is the complexity of the analysis. The Water Balance Model Express has been simplified with many of the environmental and ground conditions predetermined and entered in advance. This simplifies analysis on small sites, making it easier for homeowners and small developments to explore alternatives for rainwater management. I'm a type of person who likes to do his homework, so some of the things that on entering into the Water Balance Model Express that I feel that you should maybe just have at hand before, the location, the general condition of the site, whether it's forest or grass, soil type and depth. Most homeowner and property owners already know this, that is the soil type and depth, through previous landscaping or home improvement projects. It doesn't need to be complex. And this is something that you're going to see again and again with the Water Balance Model Express. Site size, well, that's something that's easily determined from your legal description. Roof and driveway areas, again, simple measurements or even pacing provides enough precision to go through the Water Balance Model Express. A final issue to look at is the landscape type. Do you have trees, shrubs, or grass, and the area covered by this landscaped area. I like to look at a simple sketch. I like to produce a simple sketch before I start anything. As you can see, this is a typical home in Comox, or it could be in Courtney, it could be in a number of areas. 180 square meters of roof lines, driveway of 66 square meters, and on as you can see. And then these are the sort of values that you're going to have to enter as you begin the process of the Water Balance Model Express. The first step is to enter your location. Address will do, but it's also possible to pick your location on the interactive map. Weather, soils, and other environmental data have been pre-programmed for all watersheds. And that is in contrast to the Water Balance Model itself, where you tend to get into that kind of more detail, which allows for a more detailed analysis. Step 2, create your project. Site or project name, I chose my address. Site condition, whether the site is disturbed or is it in its original condition, forest versus grassland versus developed site. Soil type ranges from clean sand to clay to loam. Soil depth, depth to till or is a measure of the depth of to till or hard pan. These range from as little as 2 inches, 50 millimeters, to as much as a meter. Beyond the meter, it no longer matters. Has very little impact on the assessment that the Water Balance Model Express will perform. And of course the lot size and site area. Last but not least, remember to hit create my project. In my example, I'm considering the effects of the addition of a coach house to a lot that already has an existing home. I would like to begin by determining the effects of adding the coach house with no rainwater management. To begin with, for the purposes of our time here today, I want to create a baseline by adding the existing buildings. To do this, click and drag the gray building block into the dialog area and add the dimensions. You literally just grab the building, drag it into the dialog area, and then from there the questions will start to pop up, and just fill in those details that we were mentioning earlier. Hard surfaces, another one of the blocks, consist of patios, driveways, and walkways. Click and drag the hard surfaces box into the dialog area and enter the area of these combined surfaces. Surfaces such as permeable pavers can be modeled by choosing gravel over paved surface. The stream health gauge, where you start to begin to see it at this point, is also a measure of the ability to conserve water on site and simultaneously reduce flooding. So stream health basically equates to the benefits that accrue to our infrastructure. The gauge ranges from a reading of 1, which is very good, to a low of 0, very bad. At this point, we've added the average house, average driveway on an average lot, and we're sitting at 0.39. And I think that again represents where many of the properties in Comox or Courtney are sitting. The next step is to add your landscaping. Again, click and drag your landscaping box into the dialog area and add the information requested. You can use sliders to adjust the soil type and depth of your landscaped areas. Interesting thing that when I was working through this, I started playing with the soil types and depths and the areas of the landscaped area, in particular the grass. It didn't seem to have much benefit or detriment to the gauge, the project gauge, to the stream health gauge. This is largely because at this point, while the grass may be intercepting runoff that falls or rain that falls onto it, it's not in a situation where it's automatically intercepting runoff from the impervious areas. So it's kind of a benign instrument at this point. Now we're going to add a coach house. And to begin with, now that we've created our baseline, now we can begin measuring the effects of a typical coach house where no rainwater management tools have been employed. Following the same click and drag process, we can add additional buildings and hard surfaces to account for our coach house. Having added an additional 75 square meters of building and 130 meters of driveways and walkways, our project gauge drops to 0.32. So we moved in the wrong direction. As we suspected, we've added more impervious areas, and we're having a bigger load on the environment and our own infrastructure. So let's start employing rainwater management techniques to sink it, slow it, and spread it, and contain our runoff on site. This benefits the environment by conserving water and reducing flooding. It also reduces our reliance on our storm system and possibly frees capacity for other sites where rainwater management is not possible or practical. Using the click and drag motion, move rain garden with storage to the dialog box. Enter this, the building or surface that will be directed to the rain garden. Very important because, again, the water balance model is looking to compensate by directing some of that impervious area to this rainwater feature. The area of the rain garden, I've chosen 4 square meters. You can actually, it's a very small value. If you were to take 2 of those larger tables and put them together, you have an area of about 4 square meters. Adjust for rain garden depth, I've chosen 200 millimeters. Enter soil type and depth. I've entered my original project values. Enter the material type and depth that we will construct the rain garden with. I've chosen river sand, a common material that we use around here, with a depth of 200 millimeters, 8 inches. By directing the runoff from my proposed coach house to a 4 square meter rain garden, we have effectively returned our site to its original condition. This feature is no larger than a common landscaped area and serves many of the same aesthetic purposes. This is something that Judy would be comfortable building, and it's well within the means and the complexity of any landscape company to build. It's not a big deal is what I'm trying to get across. We began with a site rated at 0.39. We're now sitting at 0.38. Let's see what it takes to improve on that. In similar fashion, we can add an infiltration swale with storage. We enter in the dimensions of the swale. I've chosen 4 square meters again. Pick the building or hard surface that we will direct runoff from. I've chosen to direct the runoff from our new driveway. Adjust the infiltration swale and depth. I've chosen 300 millimeters. Choose soil depth and type. I'm using the original project values of heavy clay with a depth of 300 millimeters. Choose the material type and depth that you will construct the swale with. I've chosen river sand with a depth of 200 millimeters, similar to our rain garden. By directing the new driveway and walkway to a second rainwater management feature, we have now improved our project gauge to 0.45. We've actually exceeded our original conditions, and we're moving in the right direction now. So let's see what it takes to get into the green zone. We're very close to it. The green zone being the point on the gauge where we're getting to where Jack would like to see us, I guess. The green zone not only represents the point where we begin to restore our natural features and natural environment, but also the point where we begin to reduce the burden on our existing infrastructure. By directing the existing home and hard surfaces to a 4 square meter rain garden and a 4 square meter swale, we can raise our project gauge to 0.58, just on the brink of the green zone. Again, these are relatively modest landscape features, proving that rainwater management is not an overly large burden or complex one. A few conclusions on the Water Balance Model Express. The Water Balance Model Express is a simple online tool that allows homeowners and small developers the ability to explore the means by which they can compensate for their effects on the environment and our aging infrastructure. With the Water Balance Model Express, we finally have a means to engage the general public and educate them on the simplicity of implementing their own on-site rainwater management tools. I was also asked to look at some larger developments. What is typical? These are features from a recent development at the very bottom of Lancaster. The road itself is called Dakota Place. Larger developments benefit from many of the same rainwater management tools as the smaller sites that we've been looking at. This includes rain gardens and infiltration swales. One tool available to larger developments but not practical for smaller sites is the detention pond. Detention ponds address the peak discharge from a site but only address the total discharge when combined with other previously mentioned rainwater management tools. Detention ponds do carry with them the added benefit of improving water quality and providing a green space amenity. Infiltration swales. The use of an infiltration swale in parking lots is another application that lends itself to larger developments. When applied, infiltration swales can conserve water, reduce flooding by returning runoff to the groundwater to the groundwater table. Infiltration swales also provide temporary storage and serve to improve water quality by filtering the runoff before discharge to the ground or to the municipal storm system. Now, Derek isn't here today, but Derek likes numbers. He's another member of our CAVI team. So we wanted to do some sort of cost comparison as to the cost of implementing rainwater management. So this is for that same Lancaster Heights 27 lot subdivision that I've just had a few pictures from. And you can see that these are all additional costs over and above typical big pipe that you see in any of our subdivisions. So essentially it was an additional $3,705 per lot to implement stormwater management. A review of capital costs in a recent development in Comox. We need to accept that implementing rainwater management results in an increased cost in the short term. This has certainly been my experience. In this case, the increased cost amounts to $3,705. Trying to look at the long-term cost advantage is a bit tricky, but I would suggest the following perspective. As with all municipalities, Comox has development cost charges. We've recently reviewed and changed our stormwater, our DCCs, but up until now we've had a DCC, a stormwater DCC, with a value of $3,432. Every lot that was created in Comox had to pay that out. What did that do? Well, that was used for large trunk systems that weren't necessarily analogous to the lots that were being created, but was there to create capacity in these larger systems. In many cases, these mains weren't actually in very good shape, and they would have lasted for decades beyond, but they no longer have the capacity. Limited in nature, these projects also only address the conveyance issue. They didn't provide us with the benefits of conserving water, protecting their environment. They only dealt with that one narrow aspect of relieving flooding. Cost comparison. So the net difference in cost between our two alternatives is minimal. In this case, only $273. However, as previously mentioned, rainwater management serves to solve many problems, including flooding, water conservation, an improved environment, and reduced liability to the municipality. So in closing, the water balance model is a system best applied to larger developments and regional stormwater planning. However, with the introduction of the Water Balance Model Express, homeowners and small landowners can now begin the process of exploring how they can make a difference in improving our environment and extending the life of our infrastructure. With that, I'll turn it back over to Kate.
All right.